Hello all. Today we are going to solve the problem on source transformation. So the given question is find the potential difference between the terminal n and n in the network shown in figure using the source transformation. As you can see, this is a network which comprises of the terminal m and n. So m is at a higher potential where n is at a lower potential. So you can see different type of passive elements available. So now you need to calculate like the voltage between M and N. So first of all, we can have some assumptions. As you can see here, there is 1 ohm and 4 ohm resistor. You can ignore 1 ohm and 4 ohm resistor of these branches. You can see these two branches. Let me point out. So consider this 1 ohm resistor and 4 ohm resistor. That resistor, those resistors can be ignored. Okay. So let me ignore those two resistors. Okay, that is the first assumption I'm going to make. So next one, you have to convert 15 volt into 3 ohm. 15 volt is series with 3 ohm. That will be converting. How you are going to convert? So please have a look. 15 ohm. 15 ohm is series with 3 ohm, right? So 15 ohm, sorry, 15 volt series with 3 ohm will be converted into 3 ohm parallel with the corresponding resistance. So first of all, you have to calculate the current. How to calculate the current? I is equal to V by R. That is equal to 5, right? 5 ampere. Okay, this you are supposed to consider. Here you need to replace 3 ohm. Okay, 3 ohm parallel with 5 ampere current source. 5 ampere current source. In this case, what is the current? Current is nothing but voltage by resistance. Okay, that means 5 ampere. That means 5 ampere parallel with 2 ohm resistor. That you are supposed to do it. Correct? So that part let us modify. I'll be showing you the simplification so that you will come to know how the simplified circuit forms. Let me drag the diagram. Yes, 5 ampere and 3 ohm. 15 volt series with the 3 ohm converted to 5 ampere parallel with the 3 ohm resistor. 1 ampere, it will be like this only. 1 ohm will be ignored. 4 ohm also will be ignored. Only 2 ampere is existing. Now in this right side, you can see 10 volt series with the 2 ohm is nothing but 5 ampere parallel to 2 ohm. Now you can see the same direction of current. You can add opposite direction of current. You can subtract. Here 5 ampere and 1 ampere is nothing but 6 ampere. Where in the opposite direction 2 ampere and 5 ampere. What is the result? That will be 7 ampere. So, the difference you can take out. That means 7 minus 6 is nothing but 1 ampere. 1 ampere will be in the downward direction because in the downward direction, the magnitude is 2 plus 5, that is 7 ampere. Upward direction, it is 5 plus 1, 6 ampere. So, of course, the current will be flowing on to downward direction because the downward current dominates to current which is moving on to upside. That is very clear here. Yeah, but in light of this, we'll be writing like 1 ampere. That is, then you have to simplify the resistor. Like 3 ohm and 2 ohm are in parallel. So what is the result? 3 into 2 divided by 3 plus 2. R1 R2 by R1 plus R2. The result is 1.2 ohm. Therefore, 1 ampere is parallel to 1.2 ohm. So then what you are supposed to do? 1 ohm is parallel to 1.2 ohm. So now that you are going to convert into voltage source. So here V is equal to I into R. That means 1 into 1.2. 1 into 1.2 means 1.2 volt. Okay. Then the resistance value is equal to how much? 1.2 ohm. So 1.2 volt series with the 1.2 ohm resistor. That is ultimate equivalent circuit you are able to obtain. So let me show you those diagram. So that means 1.2 then series with the 1.2 volt. In between, you can mention the upper terminal that is M and lower terminal N. So tell me what is the voltage right now? It is 1.2 volt. The voltage is 1.2 volt. So these kind of problems you can expect for your upcoming university examination. So be prepared about this and you can solve the similar kind of problem. So in the coming session, I'll be solving few more problems on source transformation. I wish you all the very best. Happy learning. If you have any queries, please do let me know. Thank you.